Nan. Turns out, the infant allergy mystery. Your baby's diaper looks like a crime scene, blood mixed with mucus. You rush to the emergency room convinced something is terribly wrong. The doctor runs tests. Everything comes back normal. Blood work? Fine. Infections? None. Your child seems happy, playing, gaining weight normally. So what's actually happening in that tiny intestine? And more importantly, why do some babies grow out of this bizarre condition while others are stuck with severe food restrictions for years? The answer might have less to do with your baby's immune system and more to do with what they ate in their first weeks of life. Welcome back to Turns Out. I'm your host, and today we're diving into one of pediatric medicine's strangest puzzles. An allergy so specific, so weirdly non-dramatic in some ways, and so unpredictable in others, that doctors have spent decades trying to figure out who gets better and who doesn't. Before we go further, you need to know what we thought we understood about food allergies. Most people think allergies are straightforward. Eat peanut, get hives, swell up, possibly die. That's the Hollywood version. That's IgE-mediated allergy. Your immune system recognizes peanut protein as dangerous, creates IgE antibodies, and when those antibodies meet peanut again, they trigger mast cells to release histamine. Drama. Immediate. Obvious. But food protein-induced allergic proctocolitis, or FPIAP if you want to sound like you belong in a pediatric gastroenterology conference, is the quiet, confusing cousin nobody talks about. Non-IgE mediated, no antibodies waving red flags, just inflammation in the colon and rectum that causes your infant to bleed into their diaper. Doctors have known this condition exists for decades, but the mystery has always been the same. Which babies will naturally grow out of it, and which ones will still be struggling at age 3? This new research comes from Beijing Children's Hospital under the leadership of researchers Gao Wei, Ye X, and their team. It was published in April 2026 in Translational Pediatrics, a journal that sits at the intersection of clinical observation and research science. What makes this particular study matter is its scope and timing. These weren't anecdotal case reports. This was a solid retrospective cohort of 163 children, systematically tracked, with follow-up data collected in 2025. Real numbers, real outcomes, real potential to change how doctors counsel panicked parents. Here's what they did. Between January and July of 2024, the Beijing Children's Hospital team identified every infant who came through their doors with a FPIAP diagnosis. 163 kids total, 84 boys, 79 girls. The median age when symptoms first appeared was 2 months old. Now these weren't random kids. Each one had been through the diagnostic process. Bloody stools, visits to the doctor. Usually some testing to rule out infection or other scary things. The diagnosis landed: allergic proctocolitis caused by food protein, most commonly cow's milk protein or soy. Think of it like this. Imagine you're trying to figure out why some houses in a neighborhood flood during heavy rain while others stay dry. The obvious answer is that the ones that flood must be lower elevation, right? But sometimes that's not it. Sometimes it's about how the gutters were installed, or what happened to the drainage system during construction, or even something about the soil composition from when the house was built. You need to look backward in time, at the conditions when the house was new, to understand what happens later. That's essentially what this team did. They collected data from medical records. They documented early feeding practices, whether kids were breastfed exclusively, if formula was introduced, when solids started. They looked at whether other family members had allergies or atopic conditions. Then in June 2025, they followed up with families. Can your child now eat cow's milk? Soy? Did they develop eczema, asthma, hay fever? The results were striking in their nuance. Here's what they found. Most kids did grow out of it. By the time they were older, and we'll talk about exactly how much older in a moment, the majority could tolerate the proteins that initially caused problems. But, and this is critical, a meaningful subset never developed that tolerance. They're still restricted, still avoiding, still managing a chronic condition. The specifics matter. Children who developed tolerance did so, on average, by around 18 months of age for cow's milk protein and slightly later for soy. That sounds like a long time when your 6-month-old can't drink regular formula, but it's actually relatively quick in allergic terms. Here's where it gets interesting though. Age at symptom onset didn't predict tolerance development the way you might expect. Whether your baby started bleeding at 1 month or 4 months didn't strongly determine whether they'd be fine by 2 years. What did matter? And here's the part that caught my attention. Exclusive breastfeeding duration. Children who had been exclusively breastfed for longer periods showed a notably better prognosis. Now, causation versus correlation. Always the question. But the signal was clear enough that the researchers flagged it. Family history of atopy also mattered. If your baby's parents or siblings had allergies, asthma, or eczema, the baby was more likely to remain intolerant for longer. Gender showed up in the data too, though the effect size was modest. Boys and girls had slightly different trajectories toward tolerance. The research team was careful here. They acknowledge they don't fully understand why. What does this actually mean for the real world? If you're a parent dealing with this right now, this research is both reassuring and specific. It's reassuring because it confirms what doctors have suspected. Most kids get better. 90% isn't the exact number from this study, but the direction is clear. Your child will probably be able to eat normally eventually. But the specificity matters too. This research suggests that doctors might be able to say, your child has a 70% chance of tolerating cow's milk by 18 months, but because there's family history of eczema here, we should check back at 20 months. That's different from maybe, probably, we'll see. This is prediction, evidence-based prognostication. The limitations are real, though. This is a single hospital's retrospective data. It's observational, not experimental. We can see patterns, but we can't say definitively that breastfeeding caused the better outcomes. There could be confounding factors. Families who breastfed longer might have had better access to medical care, or different genes, or different early bacterial exposures. The study suggests directions, not definitive answers. Within the broader field of pediatric food allergy, this research sits at an interesting crossroads. Non-IgE-mediated allergies have historically gotten less research attention than their dramatic IgE cousins. Everyone funds peanut allergy research. Everyone understands anaphylaxis. FPIAP? It's quieter, it's slower, it usually resolves, but it affects real families, causes real stress, and this study treats it with the scientific rigor it deserves. The findings raise genuinely intriguing questions. Why does exclusive breastfeeding protect against prolonged food protein intolerance? Is it something in breast milk itself? The antibodies, the prebiotics, the microbiome shaping compounds? Or is it the absence of formula, which contains foreign proteins, or both? We don't know yet. Someone should study that. Probably someone will. Similarly, the gender differences are fascinating and underexplored. Why would boys and girls have different trajectories toward tolerance? Immune system differences? Hormonal factors even in infancy? Genetic differences in how they process food proteins? All speculation at this point. But this study puts a flag in the ground. Something's different. There's also the question of whether the findings from Beijing Children's Hospital will replicate in other populations. Dietary patterns vary globally. Breastfeeding rates differ. Genetic backgrounds matter. Does this hold in Europe? In the United States? In Africa? That's the natural next step. The research also underscores something important about pediatric medicine. Sometimes the most significant discoveries come not from molecular laboratories or genetic sequencing, but from careful observation of outcomes. Looking backward at what actually happened, what factors present early correlated with health outcomes years later. It's unsexy science sometimes. It's not CRISPR or organoids or breakthrough drugs. It's asking better questions about data you already have. Here's the single most striking takeaway from this research. Your baby's feeding situation in their first weeks of life might predict their immune tolerance months later. Not definitely, not absolutely, but measurably. The immune system isn't just something your child is born with and stuck with. It's shaped, molded, influenced by,